A final kind of inductive argument that I want to go over in this class is a causal inference. And what we often see are events that are correlated with each other. One event is followed by another. And we see patterns in events. When the weather is 80 degrees on a spring day, the grass grows. And we see that happen over and over and over and over again. And so we come to see these correlated events as being causally related and with very good reason. So causal inferences, however, are inductive because there's no necessity that two correlated events have a causal relationship with each other, especially when we consider that there might be causes that are not seen, that are not understood. Oftentimes when we get sick, we, try to identify what the cause of that sickness is. We might be right about it, but there are times where we're wrong about how we got sick. But nevertheless, we use inductive reasoning to try to figure out what the cause of the sickness is so that we can avoid getting sick in the future. So with very good reason, we make causal inferences and we base them off of correlations that we experience and think have a causal relationship between each other. A causal inference is an inductive argument, therefore, and there's two directions that it can go. One direction that it can go is it can go from what we believe to be a causal relationship between two things, helping us to infer an effect. Okay, so a good example of that would be you just realized that you left bread in the oven and no timer to turn off the oven. Okay, so premise one would be that the bread was left in the oven. Okay, and that's just something that happened, and then we infer without seeing the bread. Without knowing exactly what happened, we infer that this would have been cause for the bread to be burned. So the bread is burned. Okay, so in that case, we go from the cause to the effect. The burned bread is the effect of this. But causal inferences can also go from the effect to the cause. And, a profession that normally engages in this is detective work. They go to a crime scene and they see all the effects of the crime, and then they try to piece together what caused this crime scene to happen. So they're going from the effect and then inferring the cause. But a less extreme example would be, suppose that you are eating bread and it's very dry. Okay, the bread is dry and crispy, let's say. Okay, so that's the effect, and then we're trying to infer what caused that to happen. So the conclusion is the bread was left in the oven too long. Okay, both of these are inductive arguments. The premise is what is known. Okay, but the conclusion is not certain. But the more we do see common patterns and correlations in nature, the more we see things get burned when they're left in the oven, the more likely it is that the conclusion's true. And I would say that, this is going to be a pretty good argument, as is this one. So both appear to be strong in that we would expect the conclusions to be true given the evidence. But you can go wrong with causal arguments if you there's a specific fallacy called a false cause fallacy, which essentially takes it makes a bad inference regarding a cause and effect relationship. And a good example of that would be going from a cause. Well, actually, let's go from a cause to an effect. Okay. Consider this argument here. So every time I wore socks, my team won. Okay, so let's just say that that's a fact. Okay, so then premise 2 is the cause. Wearing socks makes my team win. Okay, and then let's go ahead and use it. State another premise. I'm wearing socks. And then my team will win. Okay. This kind of looks like a prediction. It's about the future. But it's really best understood as a causal argument, because the premise that's really doing the work here is premise 2. This claim that there's a causal relationship between wearing socks and one's team winning. And that serves as the kind of key evidence that leads us to this conclusion. But this is a fallacy, because this is a false cause. While there does seem to be a correlation between wearing socks and one's team winning, we know that's not a causal relationship. It's just a kind of a lucky occurrence. There's other causal factors at play. Most likely including, how the team did that day and so on. Okay, so this would be an example of a weak causal argument, a false cause fallacy. Okay, and it illustrates, I think, as well, the inductive nature of the conclusion. We might be wrong about the causal relationship between things that we assume in our premises.